Welcome to The Explainer, everyone. Today, we're diving into an absolute paradigm shift. We're talking about analytics and predictive influencers. You see, we're looking at how predictive analytics is evolving from just, static math, literally just guessing what might happen, into these incredibly dynamic, self-adapting systems that actually influence the future. We are talking about moving from a world where algorithms merely read the data to a world where they actively shape it. It's wild.
Okay, let's just quickly glance at our roadmap for today. We're going to hit the predictive analytics boom, then enter generative AI, move into game theory and prediction, explore evolutionary prediction games, and wrap it all up with the 2026 reality check.
But to really understand exactly where we're going with these predictive influencers, we first have to wrap our heads around the massive scale of where we're starting. So part one, the predictive analytics boom. Just look at the sheer trajectory here. We are looking at a market literally quadrupling to $78.59 billion by 2032. I mean, businesses are fundamentally shifting from just guessing to actually knowing. They're generating these unprecedented volumes of data and spending billions, with a B, to extract meaningful insights, all to anticipate customer behavior and proactively address risks before they even happen. Now, for decades, this classic four-step loop has basically been our foundation, right? You collect your historical data, train a model, evaluate how accurate it is, and then, tweak the math, which data scientists like to call adjusting the hyperparameters. This whole process relied heavily on classical statistics and lots of manual fine-tuning just to spit out a single static prediction about the future. And hey, it worked beautifully for stable conditions, but it definitely had its limitations. Because think about it. What happens when those traditional models hit a brick wall? What happens when you've got missing data, totally unprecedented market shifts, or when executives just flat out don't trust a black box algorithm they can't understand? Well, that brings us to section 2. Enter generative AI. See, generative AI accesses this incredible communication and synthesis layer. We're moving away from rigid, highly structured numerical databases and shifting to multimodal inputs. That means we can now feed the AI things like text and audio, not just spreadsheets. We're transitioning from a single point forecast like, sales will be X, over to these probabilistic scenarios where the AI literally talks us through multiple possible futures. Oh, and instead of just averaging out missing data, generative AI actually creates high-fidelity synthetic data to fill in those gaps safely. It is a total game changer. So the really crucial takeaway here is that Gen AI doesn't replace our traditional statistical models. It enhances them. Think of it as an executive brain that actually explains the rationale behind the numbers. Like, if an algorithm predicts a 5% rise in demand, the generative layer can instantly output a plain language report explaining exactly why. Maybe it spotted an upcoming heat wave or factored in a new promotion. It actively bridges that huge gap between raw mathematical insight and actual human action. Okay, let's take this to the next level and see how all this builds when we introduce the messy reality of competitive human behavior. Section 3, Game Theory and Prediction. As we talked about, traditional models kind of treat the world like a static spreadsheet. I always like to think of the weather. Predicting rain tomorrow absolutely does not make it any more or less likely to actually rain, right? But game theory? It introduces a fundamentally different reality. In competitive environments, we're talking stock markets or cybersecurity defenses, the very act of making a prediction actively influences the market's next move. If a big model predicts a stock is going to crash, while investors panic, they sell, and boom, the stock crashes. It's this continuous, live feedback loop. And by mapping out these variables, like expected payment versus the probability of winning, we can literally mathematically model investor psychology. We can map out risk sensitivity and that continuous push and pull of market equilibrium. You see, machine learning is absolutely fantastic at pattern recognition in vast data sets, for sure. But game theory? That provides a strategic lens. It helps us understand how a rational human decision maker is actually going to react to those patterns. Which brings us to the absolute cutting edge of multi-agent modeling. Because when you combine machine learning with game theory at scale, you get something truly incredible. Section 4, Evolutionary Prediction Games. I want you to think about this carefully for a second. If a navigation app on your phone tells everyone that a specific route is the fastest, what happens? All the users react and take that exact route. And suddenly, that route is completely jammed, which instantly invalidates the underlying data the model literally just relied on to make the prediction. The prediction itself altered the reality. This phenomenon creates what researchers are now calling evolutionary prediction games. In this dynamic, both the AI and the users are acting as predictive influencers. Disparities in prediction quality pop up. Users respond by either increasing their engagement or adopting new trends, and this repeated learning creates this massive, continuous, co-evolutionary loop. The algorithms and the humans are constantly shifting and shaping one another. Now, you might be thinking, wouldn't this loop just lead to total chaos? And honestly, in perfectly idealized lab settings, you might actually see one algorithm just completely dominate the market. But realistically, when we factor in constraints like finite data and limited processing power, this loop actually forces the AI models and the human participants into a really balanced, mutualistic symbiosis. Simply put, they have to adapt to survive together in the ecosystem. It's almost like biology. So, how is this highly advanced theoretical stuff actually being applied in the real business world right now? Let's ground this. Section 5, the 2026 reality check. You see, the hype and buzz of early Gen AI experimentation has definitely met a strict reality check. In 2026, CFOs aren't just playing around, they are demanding proven financial ROI. Because of this, we're seeing a massive shift towards small language models and edge AI. Basically, this means putting the computing power directly where the data is generated, allowing for much faster, localized processing without that annoying latency. But even more importantly, we're seeing the rise of highly agentic workflows. This means AI is no longer just some passive dashboard tool you check in the morning, it's becoming an autonomous worker. For instance, if a predictive model foresees a sudden supply chain disruption, a generative AI agent can automatically negotiate with alternative suppliers and draft up a brand new contract on its own. These are literally the building blocks of what we call self-healing business systems. Which leaves us in a really fascinating spot. As we hand over the execution keys to these brilliant self-adapting systems, the role of the human is fundamentally shifting from being the worker to being the editor or the governor. And it leaves us with one incredibly provocative question to ponder. In this evolutionary game of strategic data and self-healing systems, are we still the active players? Or are we just becoming the audience, watching the ultimate predictive influencer at work? Well, thanks so much for joining me on this explainer today. I really hope this helped map out the incredibly dynamic future of analytics for you. Catch you next time.